Welcome to Chapter 5, Section 4, Factor and Solve Polynomial Equations. You're going to have to take back a lot of the factoring we did from Chapter 4 and remember how to do some of it here. So a prime polynomial is a polynomial that cannot be factored. Okay? So if you started with something like x squared minus 4, this is not a prime polynomial. A prime polynomial would be what it is after we have factored it. This is prime. Factored completely is very similar. Factored completely is when all factors are prime polynomials. Okay? Which means if you had something like x cubed minus 4x, you could factor this in x squared minus 4. But this is not factored completely. You have to factor the entire way so that you can't factor any of these terms any further. This is prime. These each are prime polynomials, and you know then that it's factored completely. Factor by grouping is when you pair monomials, when you pair terms with common polynomials, common monomial factors. And then you factor after you've paired them. All right. And quadratic form is an expression of the form of the ax squared plus bx plus c. All right, it's an expression of this type. It might be though that x we're going to replace in the book. It says au squared plus bu plus c, where u can be anything. Okay? And what I mean by u can be anything means that you could have an equation that is a xy squared plus b xy plus c. And you could factor this normally, except there's an xy there and we get scared. Instead, quadratic form is anything in this form. I mean, you could have a sine squared theta plus b sine theta plus c. You can factor this just like everything else. All right, here's some definition stuff that you just need to fill out. A polynomial with two or more terms is a prime polynomial if it can be written as a product of polynomials of lesser degree using an integer, coefficients and constants, and if the only common factor of its terms sorry, I need to erase this. I didn't quite read this very carefully. It says a polynomial with two or more terms is a prime polynomial if it cannot be written as a product of polynomials of lesser degree using blah, 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 blah. And the only common factors of its terms are itself and 1. So 16x squared minus 4x plus 8 is not a prime polynomial simply because 4 is a common factor of all of its terms. A polynomial is factored completely if it is written as a monomial or the product of a monomial and one or more prime polynomials. Here's an example. It is not factored completely because x squared minus 5x can also be written, can be factored into x minus 3, x minus 2. So that's why it's not factored completely. You just have to have this part filled out. Mathematically speaking, we'll see some stuff here in a minute. So here are some special factoring patterns again. Here's the sum of two cubes. It follows this pattern. If it's a perfect cube plus a perfect cube, you write a plus b, and then, let's see here. So x is a, b is, I'm sorry, a is x, and b is 2. So then that means a squared minus a times 2 plus 2 squared, which ends up being x squared minus 2x plus 4. All right? That's one of the factors. The difference is exactly the same except the sign. I mean, look, a plus, that's a minus, plus. Here's a minus, here's a plus, plus. So basically, you need to add those pieces in there. So a is this, b is this. All you're doing is plugging in the information. A is a squared, so that's 2x squared. Plus a, which is 2x, times b, which is 1, plus 1 squared. And so what we end up with is 4x squared plus 2x plus 1. All right, these are some special patterns to try to recognize. All right, so difference of cubes, of two cubes here. So the way this has to be written is, this is basically z cubed minus 5 cubed. So a is z, b is 5. So we follow the pattern here. Make it so you can see it better. Follow the pattern. So it's z minus 5. And now it's a minus 1, so it's difference. So a squared. A is z, so z squared. Then it's plus ab. Well, it's a times b, so plus 5z. Then plus b squared, which is 25. Here, it doesn't fit any of those patterns until we factor out the monomial 3y. If you factor out 3, you get 27y cubed plus 64. That tells me that a is actually 3y and b is 4. And here's why. You have to write it in parentheses. 3y cubed. 3 cubed is 27. Y cubed is y cubed. And this is 4 cubed. you have to follow the pattern. Here's a cubed plus b cubed. So a is 3y plus b. A is 3y, so that's being squared, minus 3y times 4 plus 4 squared. So I'm having trouble writing this in the space they are providing. 3y plus 4. 3y squared, that's 3, this gets distributed. 3 squared is 9y squared, minus 12y plus 16. All right, now let's practice this pattern. Let's start off by saying that this right here, let's factor out an 8. Both of these can be divisible by 8. Gives us an x cubed plus 8. Now, we follow the pattern. Now we follow the pattern. X is, well, actually, let's rewrite it like this. So x in parentheses cubed plus 2 in parentheses cubed. So a equals x, b equals 2. And we follow this sum of two cubes. So we write a plus b, a squared minus a times b, so 2x, plus b squared, which is 4. So we're following this right here, this pattern for those numbers. Guided practice number 1. This is number 1. All right, we can't factor this as is, but we can factor out a monomial. All of these can be divisible by, are divisible by x. So take out an x. Once that happens, you should start to look, and you can use Waddell's method. You could use completing the square. You're going to now factor this by looking at the factors of 10, 110, 2, 5, and see if you can make them equal 7. So this is factored completely. Number 3, 16b to the 5th b to the 2nd. All right. Well, I'm going to assume all of these can be divisible by 16. I'm hoping. I really don't want to try to factor 686. Oh, it doesn't. It's not divisible by 16. But we do know it's divisible by 2. They're both even. 16 divided by 2. So we take a 2 out. And an 8. We also need to look at the fact that here's a b to the 5th and a b to the 2nd. So if we factor out, divide by b to the 2nd, we end up with 2b squared outside. And inside, 16 divided by 2, subtract those numbers becomes b cubed. Plus 343, which I think is a perfect cube. And so what I have is I have that special pattern, and I had to use the calculator a little bit. It's 2b cubed plus 7 cubed. All right, and we can factor this part completely. You factor it completely by using one of these patterns. 2b squared on the outside. A is 2b, b is 7. So that means it's 2b plus 7. And on the outside, or the next part, it's a squared minus a times b plus b squared. So my final answer, 2b squared, 2b plus 7. Squaring both pieces inside of there, 4b squared minus 14b plus 49. This has now been factored completely. There's nothing else you can do. All right. Factor by grouping. Factor by grouping, again, is a method in which what you're going to rearrange the problem. So basically what it's dealing with is in the book here it says an RA plus RB plus SA plus SB. Okay? So you're going to rearrange this. These are all terms. You know, this could be an x squared, it could be whatever. But you're going to rearrange it so that RA and SA are together. And you can rearrange it so then that RB and SB are together. And once you rearrange it so that a common factor can be brought out, here and here, you look at each of those pieces individually. RA, SA have an A in common, R plus S. Do you see? I hope you all see that. On this side, RB, SB, they have a B in common, R plus S. All right? And now in between, look, all of a sudden R plus S, they both have an R plus S in common. And so all you do is you take out the R plus S, and you just keep what's left over. All right, you take out what they have in common. So look here, x cubed minus 2x squared minus 9x plus 18. Well, look, these two have some x's in common. This has a 9 in common. So factor by grouping means you rearrange it so that it has common monomials to factor out. Factor an x squared from here, leaves you with an x. Factor a minus or an x squared out of there means minus 2. Here, we're factoring a negative 9 out, so forget about this part. Take a negative 9 away from here, you get x. Negative 9 away from here, minus 2. And what you can see now is that, or hopefully you see, is that this piece and this piece are identical. So once you know they're identical, you take them away, x minus 2. Take it out of each term. And then rewrite what's left over, x squared minus 9. You have now factored by grouping. The difference of two squares, well, Don't think you're done just because you did one little step. X squared is x minus 3. X squared minus 9 is x minus 3. X plus 3. That's factor by group. All right. So let's take a look at this piece right here. The first thing for part B, oh, here's B, that they have is, well, let's rewrite this in, okay, I see what's happening here. We're going to make this 9x squared squared. And this is 16 squared. So take a look. 81 is 9 squared. X to the fourth is x squared. Basically what's going on is you're pretending that x to the fourth is something else. Because now it's a difference of perfect squares. 9x squared minus 4. 9x squared plus 4. It's factored completely. Well, actually, if you look here, here's a difference of perfect squares. So this becomes 3x minus 2, 3x plus 2, 9x plus 4. Right? So it's hard to determine when things are factorable sometimes. Take a look at this example, part B. Rearrange them so that they have things in common. Well, oh, I'm sorry, factor out a 3y cubed. See? Y, y, y. When you take a 3 away from here, it becomes a 1. When you do 7 minus 3, it becomes y to the fourth. 15 divided by 3 becomes a negative 5. Minus 3 from the 5, you get y squared. Same thing here, divide by 3, and you get, that's it, the 6. All right. So what we have now is 3y cubed, y to the fourth, y squared plus 6. And this is really scary to me. I think it's probably scary to you as well. So what you do is let's just pretend that y to the fourth, I'm sorry, pretend y squared is equal to a. All right? Because when you do that, this y squared becomes 5a plus 6. Y to the fourth actually becomes a squared. And now this is something that is factorable. We've actually already factored it once today. It's an x minus 2 and an x minus 3. I'm sorry, not x. A and a. All right. Once we do that, though, you have to remember what a is equivalent to. A is equal to y squared. So you got to put that part back in there. And thankfully, nothing else can be factored. So we're going to do a lot of these examples in class, hopefully. All right, checkpoint. Factor each polynomial completely. This one here, we need to factor by grouping. And it's already set up for us. Take an x squared away from the first two terms. So we're grouping this together, grouping this together. Well, when we take that away, becomes an x plus 2 minus. Look at 25x minus 50. Well, we can take a 25 out of both of those. Take a negative 25 from there, x is left over. Take a negative 20, divide this by negative 25, you get plus 2, which makes us happy because you should see now that this part and this part are equivalent. So, we factor out the common part. Whatever's left over is good. Now, if you get to this point, I'm going to be so happy that I'm not going to care that you don't finish this. But please try to recognize that x squared minus 25 is the difference of two squares. Here, this is one of those ones where we pretended that a was something else. I'm going to pretend that this equation is actually x squared minus 14x plus 45. Because right away, I know that the factors are x minus 5, x minus 9. The reason I'm doing that pretending is because all I have to do at the end is say, hey, x to the fourth, x squared. Oh, that should be this then. And if you get this part, I'm going to be so stoked, so happy, that I'm not going to worry about the fact that you may have forgotten to factor another piece. All right. So, we're almost done. All right. So, example 4, solve a polynomial equation. You're, of course, going to want to put it into standard form. X to the fourth, subtract 10x squared from both sides. All right. Now, just like this before, pretend that this is a squared and pretend that this is not there at all. And when you do that, you can see factors of 9 that add up to 10. Not plus. Is x minus 9, x minus 1. All right, but remember, we pretended that this was a squared and not a fourth power, and a 1 and not a second power. So all you have to add on now, once you factor normally, is the squared. And of course, difference of two squares, this one here, you're looking at x minus 3, x plus 3, and x minus 1. Oh, I'm sorry, x squared minus 1, which I actually didn't see at first. It's a difference because it's subtraction, and it's perfect square, so it's once again x minus 1, x plus 1. So all of these factors equal 0, and the zero product property says that whatever, if this is 0, 3, everything's 0. If negative 3 gets put in here, everything is 0. A positive 1 and a negative 1. All of these solutions, 3 plus or minus 3 plus or minus 1, are all solutions to this equation. All right, let's look at the guided practice number 5. We're going to factor by grouping x cubed plus 7x squared minus 9x minus 63. And you're going to group them together. And we're going to first try to group these together like this. So divide out an x squared. Divide out a negative 9. And when you do that, you should see x plus 7, x plus 7. That gets taken out. And the other stuff stays behind. So, x squared minus 9, hopefully at this point you've seen it enough to know It's a square of a binomial, or a binomial, sorry, difference of perfect squares. And you have something that has been factored completely. Let's take a look at number 7. 4t to the 6th, 20t to the 4th, and 24t squared. All right, start by dividing everything by 4t squared. All of these can be divisible by 4. All of them can have a t squared taken out. So that's t to the 4th minus 10t squared plus 6. Now, factors of 6 that somehow can add up to 10. See if you can do it. So for this, you need to pretend again and imagine that this is a squared and then this is in here. Because you should be able to factor this. Oh, I'm sorry, I also made a mistake here. 20 divided by 4 is negative 5. So, when you're factoring this, you've got a t and a t. Has to add up, or multiply, be a product of 6, but add up to negative 5. So again, it's the common one we've seen over and over again. And now you have your prime factorization of this. This is the prime factorization for guided practice number 7. All right, why don't you pause the video and why don't you try to work this one out a little bit on your own and see how it goes. All right, so first thing, we need to put this in standard form. 2x to the 5th minus 14x cubed plus 24. 24x equals 0. So, looking at this, we go ahead and take out a 2. So we're dividing everything by 2. We're dividing everything by an x as well. And look at what it leaves us. An x cubed. A minus 7x. I'm sorry, not an x cubed. Next to the 4th. Next to the 4th. Because 5 minus 1 is 4. 3 minus 1 is an x squared. And we have a plus 12 at the end. So, pretend that this is a squared and this is not here. And you should be able to factor it normally. Of course, once you factor it normally, you have to recall that it wasn't normal. We went ahead and changed it. So when you go back, you have to change it back again and say that x squared times x squared is the x to the 4th that you're looking for. So 3x, x squared minus 3, perfect square, okay? And you're done. This is completely has been factored. Now, the directions ask you to find the real solutions, though. So for this one, the real solutions are at 0, 2, negative 2, x squared minus 3. That one doesn't come out nice. You have to actually add 3 to both sides. And then you have to square root both sides. And I'll be very angry with you if you forget the plus or minus. So that means my 5 different solutions are 0, square root of negative 2, negative square root 2, I'm sorry, square root of 2, negative square root 2, 2, and negative 2. These are the 5 possible solutions. All right, so here is guided practice number 8. We're doing 4x to the 5th minus 40x cubed and plus 36x equals 0. So again, can't do much here except look and see that all of these things can be divided by 4 and divided by x. So you're taking a 4x out of the equation. Divide this by 4, it becomes 1. X to the 5th, you're subtracting an exponent of 1, so it becomes x to the 4th. Subtraction of 1 here. Dividing by 4. 1 minus 1 is 36 over 4. 9 equals 0. And just like before, if you ever have an x squared to the 4th and an x squared, pretend that that's not there, because the factoring is much easier. X squared minus 10x plus 9 can be factored very quickly and very easily. You just cannot forget to put the squareds back in there. So, continue factoring because these are not prime. This is not prime. And once you are able to factor them completely, you then just have to look at it. What makes this equal to 0? 0, negative 3, 3, 1, and negative 1 are your zeros. These are the solutions to the equation. Let's also try number 10. Negative 27x cubed plus 15x squared equals negative 6x to the 4th. So putting it into standard form where it's equal to 0, you're adding 6 to both sides. 6x to the 4th minus 27x cubed plus 15x squared. Now, if you look closely here, there isn't anything really nice to come out except for the fact they're all divisible by 3. They're also all divisible by x squared. So that is what you pull out. That's a 2x to the 2x squared. That's a minus 9x. And that's a plus 5. And we haven't used Waddell's method in a long time, so we're going to go ahead and practice it now. 3x squared. Actually, let's pull it off onto another page. So, Waddell's method tells us to first combine a times c. 2 times 5 is 10. And the factors of 10 are 1 and 10. 2 and 5. And remember, they have to be plus or minus, because you could be opposite signs. And now look and say which ones of these equal b. So which one of the factors of these numbers add up to 9? Hopefully if you look at this, let's see. As you can see, it looks like 1 and 10 will work, but at no point can you get a negative 9 from a positive 1, a positive 10, and a negative 1, and a negative 10. So this right here is not factorable. So we did a little bit of work to see if it was factorable, but in the end, you're going to find out that it's not. So instead, we have to go back to the quadratic formula. You're going to hear me sing along while I do the equation, or the formula. So x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And you plug in those numbers. This is b, this is a, and this is c. So b is negative 9, so 9 plus or minus the square root of negative 9 squared minus 4 times a times c, all over 2 times 2. All right, so that's 9 plus or minus the square root of, work this out, it's 41, all over 4. So we have found out, what we found out is that We know that one of the zeros is 0, but the other 0 is 9 plus the square root of 41 over 4, or 9 minus the square root of 41 over 4. Those are the zeros that we have to work with. There's a good review problem for all the ones that we have to do later. So finish the guided practices. I did quite a few of them. So finish your GPs, and these will be some of the problems we do in class. Good luck.